Guys, welcome back to our restoration project. So we finally got through our piston installation and barrels, and we're ready to proceed with a full mock-up. So we're at a point now where we can either continue building and assume that everything's going to work out and start our engine and we'll be good to go, but really at this juncture we can't really afford to take that risk. We have to do a full mock-up and see if we're going to have a piston to valve clearance issue. The reason we're going to check this out is because we just installed our pistons. Different profile piston, the whole geometry of the thing is completely different than our original mollies. And then the cams we're putting in here, I had new profile ground to a period correct cam spec for this engine. So I don't know if that cam is going to work with these pistons. We got to find that out. There are some ways you can do some measuring and get to that equation. If you're professional, you've got really good measuring tools, they're all well calibrated, and you don't make a mathematical error, you could probably figure that out. But we're not going to take a chance, because however long it takes to put this engine together and take it apart to find our measurement that we need to find, we just need to endure that and go through it. Too much at risk here to have valves hitting the piston. So this video is going to be a full mock-up. We're going to do a piston to valve clearance measurement. We're going to find out what it is, and then if we need to make an adjustment, we'll assess the measurement and figure out what we need to do at that time. So let's go ahead and dig in and get this thing started.
Okay, so before we get started on our full mock-up here this morning, let's take a look at some camshafts, some specifications, and talk a little bit about early Porsche history as best I can tell it. The Porsche historians would be able to set me straight better than I can give this to you, but hopefully we're somewhat correct in my storytelling. So what's happened here is the camshafts that were pulled out of our car are not correct by a long shot for our engine. And this is the specifications that we're going to. So this is the grind, and these would have been camshafts for the early car, Solex carbureted, early Weber carbureted, and at some point later in '66 they had a change. So that's what's interesting. I sent them into webcam. They have ground us up some new cams using some other cores. Apparently these cores weren't even good enough to do anything with. They couldn't figure out what application they would have been for no matter what we had. So who knows what these are, but they're definitely not going to work in our engine. So I had them ground us up some new ones. So our valve overlap is going to be measured right around this range here. So this is going down into our JE Pistons quite a bit, and we just want to make sure we're not going to have a problem with 4.5 millimeters. So there was also another cam that came after this one, and we think this is the next closest one that may or may not have been equipped on this engine. Valve overlap was about 3 to 3.5 millimeters on this one. So this is a lighter, less aggressive profile. This actually was a very good camshaft grind, and is preferred by a lot of guys who do racing because of the duration and lift and things of that nature. So looking at the early Porsche history as best I can tell it here, so our 66 cars were equipped with Solex carburation and this early style exhaust heat exchange system. These images here were something I recently found, and the only images I could find anywhere online that would even show what the early style looked like. And that's pretty much it. And this set here looks to be in pretty good condition, and this recently sold for 9,000 euros. So yeah, pretty expensive set of heat exchangers. Later in '66 they went to this style heat exchangers from what I gather, and I think this one was designed for the S and eventually was adapted to all the other cars. This was the only other image I've found in the manual of the early style heat exchangers. So as best I can describe what happened in '66, you had the Solex carburation, you had the early style heat exchangers, and this was the camshaft that went with that combination, and the engine produced about 130 horsepower. Later in '66 they went with the Weber carburation, and They still have some of these as the heat exchangers for some of those early Weber cars, and it still produced 130 horsepower. Well, later in '66, they switched over to this style of heat exchanger, and also they made some modifications to the Webers later in '66, and that combination produced with the early style camshaft produced about 140 horsepower. So you had a horsepower bump with the camshaft and this exhaust, and apparently Porsche didn't like that, so they decided to regrind the cams, dumb them down, so to speak, and bring it back to within 130 horsepower rating, so that it's not really competing with the S. So, but what we're going to do, we're going to go with our early style 4.3 valve overlap. We're going to check, make sure that that's going to work, and this is going to be a much better cam profile to run with our engine. So that's why we're doing this, and hopefully we don't have any issues there. Okay, so my plan on video for this is a little bit different than we normally do, and we will do video on from this stage forward as we build the engine out for the final go-around. But for now, we just want to quickly get to the measurement by cleaning up our pocket areas here, closing this thing up, timing it, and breaking it apart, find out what we got. So I'm just going to blast through this as quickly as possible. We'll stop intermittently to talk about anything we might need to talk about that is pertinent to doing this task. Other than that, let's just go ahead and blast through it and see what we end up with. Okay, so getting started here, we're going to perform two tests, and we're going to do them separately. The first test we're going to do is we're going to install our number one cylinder head and perform a piston to cylinder head clearance check. And we're just going to do the one. That's going to help us to avoid loading everything up with clay and trying to turn the whole thing over to get that reading. So we can just do one, and we should be fine there. And also, to perform our valve to piston clearance check, it's going to be necessary to sort out our Z1 mark and find our timing and make sure we're at absolute top dead center. In this case, it really is remarkable. Our Z1 mark is so spot on. It's really, it's hard to believe that they can stamp that and get it that close. So what I'm doing is I'm taking a straight edge from the center of my case. That's straight down the center, as center can get it. I have played around with my number 1 and my number 4 pistons to find the amount of dwell between absolute top dead center and to the right and to the left of top dead center. I got my marks there. The pin and the right side of the tape there is the amount of dwell in our Z1 mark range. Z1 mark on the face here is a pretty straightforward line. On the top, it's a little bit angled, so wouldn't want to trust the top reading. The reason I have this coming all the way to the front, because the longer, the straighter the run, the more accurate we're going to be. And this will help me avoid from having to get back here and sight and see if I'm sort of on the mark. This will be much more accurate for us. But it really is incredible that they were able to stamp that out in the factory, and it is truly top dead center. And then for what to use to make our impression, a couple of different things we could use. We could use a typical modeling clay, and I've used this before, and it works really good. The only problem with this, in our situation, we have to put so much on here. To make an impression in this is very, very hard and difficult to press in. I like Play-Doh. It's a lot more pliable. It'll be easy to put on and take off, and it'll give us a real nice impression. So we're going to go with this to do our testing. You could use both, but it's going to be a lot easier on this one to run Play-Doh through all 6 cylinders and get an impression than modeling clay. Okay, and then making sure we're not going to drag it down the cylinder sides as we're rolling through. Like we're going to be clear. Okay, just filleting back there with a utility knife blade. You can see we have ample clearance on our side there as we're cresting to the dome, pretty much all the way around. It measures out at about 1.5 millimeters at its tightest point, right down as it's going into the barrel there, to about 1.75 millimeter near the top of the crest. With this engine, I'd be more than happy to run that clearance. I think we'll be just fine. All right, so that one checks out okay. So let's go ahead now and build this guy out and see what we have on our valves to pistons. All right, let's just have a quick look here at my mock-up with these washers. So these washers measure out, this one is 2.03 millimeters, which would be ideal for intake clearance. And the exhaust is 2.5 millimeters, which is ideal for exhaust. So that's basically the kind of clearance we're looking for. If we have any tighter than that, we'll have to explore our options. Getting started, so I'm wiping down the top of my piston and pockets and also the inside of the head with some oil, and then I'm wiping that oil off with a paper towel. Something like that should work for us. Okay, well, I think that should work for us. Let's cross our fingers and close her up. Okay guys, so back out here again this morning, another couple hours setting up our rockers and adjusting valve lash, also re-verifying our valve timing one last time. I honestly think my left bank here is probably going to be a better, more accurate measurement for us, just because of the way things have been going. It's quite a lengthy process, and there's a lot of things here that can go wrong, and the problem is if you got something that's going wrong, it's going to make that wrong impression in your clay setup, and you could be misled. So I really felt confident our left bank is the most accurate. However, I don't think the number one intake is something we should be looking at, because that could be highly compromised just trying to adjust the timing, get all that right. So if I had to do this again, I'd probably just leave the clay out of our number 1 and number 4 cylinders, and then once we got it timed, everything else probably just fall into place. Okay, let's go ahead and break this left bank apart and see what we got. Well, we are down inside here now and having a close-up look. To be perfectly honest, I thought we'd be a lot closer than we are. We're definitely not going to have a problem with this engine. But let's go ahead and take this one here. This is a real good impression. Our number 3 here. Let's go ahead and fillet this one and see exactly what we do have on our valve overlap. Okay, so our intake valve, this is really what we need bare minimum to make things work. You can see we're well within that range there. And our exhaust valve, 2.5 millimeters, well within the range. Yeah, no problem at all. Okay, so we got through that one safely, and I got to tell you, what a brutal process to try and find a measurement on something. A whole lot of work here. This whole process, about 14 hours to put this all together, take it down, and get our first measurement off that. I'm going to go ahead and break down the other side and just double check what we got in there, but based on what I'm seeing here, I can't imagine we're going to find anything that's going to be too concerning. But knowing this measurement and seeing this in real time here really gives us some confidence now that when we put our engine together, put it in the car, we're definitely not going to have a piston to valve clearance problem. We might have other problems, but we're not going to have that one. So that's going to do it for this one, guys. Thanks for watching, and we'll see you on the next video.